All right, here we are. Hello and welcome to another ARMS Innovation Coffee. I'm Robert Wolf, joined by this amazing co-host over here, Alessandro Grande. And in this episode, we'll be meeting with Kwabena Agiman, president and co-founder of OpenMV. Now, before diving into this episode and bringing on our guests, I want to remind everyone of a few things. And of course, we'll give you a short recap of last week's episode. So firstly, I want to make sure that you smash that like button. If you like the video, make sure you hit that like button and don't forget to subscribe to the ARM Software Developer YouTube channel. We go live every week and look forward to seeing all of you here and welcome industry experts from all over this space to share and showcase the amazing work that they're doing around this area. Secondly, all questions and comments are welcome. So make sure that you drop those in the chat and Alessandro or myself will get to them as soon as possible. So Alessandro, I'm looking over at you now. Without further ado, let's do that recap and bring on Kwabena.
Yeah. So last week, obviously, I was on my own because you were on holiday, right, Robert? So we're going to have to ask you questions about your holiday.
Yeah.
But it was a great episode actually. We had the Arduino team talking about their latest IDE, so the IDE 2.0. It was a really fun episode with a live demo from Arduino. And we got to see some of the cool features, especially the debug features on their new IDE. So it was a good episode. Go watch it on our YouTube channel. As usual, you can find all the episodes there under the Innovation Coffee playlist. And I think it's time to bring on our guest for today.
Kwabena, welcome. Let's bring him in.
Kwabena, hey.
Hello.
Awesome to have you on the show.
So real quick, I just want to there might be some people watching who are familiar with kind of our pre-innovation coffee series that we were hosting on your channel, Alessandro. We brought Kwabena on before, and some of you might already know him. But to stay true to what we do on this show, we like to do a little bit of an origin story. So Kwabena, once again, welcome to Innovation Coffee. And could you do a little introduction of yourself real quick?
Yeah. Sorry, my mic just muted itself for no reason. Hi, I'm Kwabena. I am the president and co-founder of OpenMV. I built the company with my co-founder, Ibrahim. And so OpenMV more or less writes code for ARM microcontrollers, in particular the STM32 line of microcontrollers. And we more or less are building a computer vision library that is available for pretty much any ARM microcontroller, but specifically the STM32 line of them. And this encompasses everything from booting the system up to capturing image data to doing things like JPEG compression and doing other higher level computer vision algorithms, and then outputting that data to an LCD screen or so on and so forth.
Really cool. And I've asked you this before, but I'm going to ask you again because, as we said, this is a new it's an episode on a new channel. So I'm really, I kind of know this story myself, so I'm not going to pretend I don't know it, but it's a really interesting story. What brought you to build a company to do machine learning on a microcontroller, or actually even just do like vision on a microcontroller first? And I know that you were one of the first to actually do machine learning on a microcontroller, and definitely the first to do vision on a microcontroller, right? So what brought you to even explore that space?
Oh, yeah. So more or less, I did something called the CMU Chem4 back in college, where I got basically the CMU Chem line of series of sensors were a microcontroller doing doing basic blob detection, color processing. So the first one was built on a SX48 processor, which is a very low-end PIC, basically. And those kind of upgraded until they did the CMU Chem3, which was based on like an ARM TDMI7 processor from NXP. And I did the 4 based on a parallax propeller chip. And after that, I got kind of sucked into, this is pretty neat doing computer vision on these low-end systems, because it's a high data rate that you're processing on a system that really doesn't have that much resources compared to a desktop PC. Anyway, so after that project ended, my co-founder Ibrahim saw what I did actually with the CMU Chem4, and he actually started building the OpenMV Cam based on that, which was based on the STM32 F4 27 processor. And so I started working with him, and we've been kind of jazzing together for 6 years now, more or less, designing this whole computer vision library and bringing more and more people aware to the fact that you can actually do really interesting computer vision applications on MCUs.
So I think that's an awesome story. Am I muted? Okay. I think that's an awesome story. You said 6 years ago. I'm kind of curious because this goes before my time of knowing you. When did you join? We didn't mention this, but when did you join the ARM Innovation or Innovators program?
God, it's been probably three and a half years so far now, I think.
Okay.
Something like that. Yeah.
So half of OpenMV's life.
Yeah, more or less. You guys have helped promote the product. I appreciate it.
Cool. Very cool. Yeah.
Yeah, you were on the first. I think you were in the first batch of Innovators. Actually, I think Rex had found you, or had found your project, and I think you've been invited to the first group of Innovators. So it's always been a pleasure to work with you because, I mean, every time I speak to Kwabena, so everybody knows, he's always building something new. Like I've never spoken to you, Kwabena, once, and you didn't give me an update on like some new feature that you were adding to your products. And we should say that actually this is your like side hustle, right? Like this is not really your main job either. So I've always been. You want to share a little bit about like what your day job is? I mean, if you want.
I can say I'm happily employed by a awesome company called Embark Trucks. If you are interested in helping to build the self-driving truck future, let me know. Particularly if you're an embedded systems engineer, we are hiring. But otherwise, I work at a company for my day job that builds fully autonomous semi-trucks.
And we should say that, like obviously, it goes without saying that you don't pick boring things to do, right?
yes, pretty much. I try to use the best of my degree for really cool applications. Yeah, I like doing that.
Cool.
Mm-hmm.
So I'd like to start this off. Can I kick this off with a question? It might be a doozy here, and I think we talked about this before. But I first met you at the Super Conference. I think it was like 2017 or 2018 in Pasadena, and one of the things that really struck me when we were talking and you were showing me the OpenMV camera was that you built from the ground up a IDE that is focused or specific for your OpenMV camera. Am I correct? Is that statement correct?
Yeah. Let me show you guys that.
So the question though, real quick, because I'd like to get the background, and of course I want to see it, but the question for you is, what was the motivation behind building this from the ground up? Because I think a lot of people, when you get into something like this, into a space like this, and you want to build something, you always gonna think, well, what can I go consume first? What can I take and build upon? And you said this didn't exist, and so I need to build it myself, or I just want to kind of know your motivation behind building it. And then of course, if you could pull it up, I'd love to see it too.
Yeah. So our main design goal of building our own IDE was that we needed so more or less, when you're trying to do computer vision on a microcontroller, there's no features for that. You see a lot of applications where someone tries to display an image on a serial port using ASCII, and that's like, whoa, that's super bad. And then also just making the development environments pleasant and being able to iterate better. At the end of the day, there are no tools available that kind of made that process easy at the time that we kind of launched here. And honestly, even today, there's no tools that do that. And I think it's because it actually is, it's a non-overlapping skill set for someone to be good in C and able to program microcontrollers, and then also being able to do desktop applications. And so I've been able to bring to the table for the company that kind of dual skill set in order to really enable us to have good desktop software and a good microcontroller software. Anyway, the reason why the IDE was important is because that really provides you the interface for making it pleasant to work with the system. One of the things that I like about microcontrollers is that you do have control over them, and they aren't like a separate computer so much. In the sense that the OpenMV cam, you can plug it in, unplug it, plug it in, unplug it, connect to it. It does exactly what you want. If you want to pull power at any time, you don't really risk corrupting your disk or etc. And when you connect with the IDE, you have full control over the system, and you tell it exactly what to do.
Awesome. So are you going to share your screen? Can we maybe get like a little?
Yeah.
Is that on the schedule, Alessandro? I haven't seen it. Is that okay if we go do a little peek at the IDE?
Yeah, let's do it. I mean,
All right.
it's always welcome to. I'm always keen to. We haven't mentioned actually that it leverages MicroPython. So that's another interesting feature that I think we should talk about. Maybe while you pulled that up, we can kind of prep that question. It's interesting that you've picked a high-level language to speak, or higher-level language to speak to a microcontroller, right? And I know that today, I think there is more and more microcontrollers actually using MicroPython. But back when you started, I haven't. Well, I'm not sure there were that many, right? So actually, I think you were one of the first successful projects, I should say, that like was using MicroPython. Actually, well, Adafruit was already using MicroPython, right? So, but I think when I found your project, I thought it was really interesting. I could do a lot of stuff with MicroPython on this IDE.
Oh yeah, Adafruit. Well, they weren't using our product at first. Well, Adafruit came. I think we had MicroPython before Adafruit.
Oh, did you? Okay, interesting.
Yeah. So this is the OpenMV Pure Thermal. Let me just reset the autofocus, since it focuses on whatever you are when you start the script. Okay, cool. And so this is just looking at my desk. This is looking at the IDE, and so you can kind of see what the camera is seeing, and it's streaming data back to the computer. And more or less, this is all happening on an STM32H7. So it is actually capturing the image at the QVGA resolution, so 320 by 240. We can just raise that up to 640 by 480 though. That's of course going to lower the frame rate though back to the computer just because the image is bigger. But we're capturing this image on the microcontroller and then doing JPEG compression and streaming that all back to a PC actually. The pipe for streaming it back to the PC isn't that big. We're only using USB full speeds, so that's limited to 12 megabits a second. So you don't really want to push the resolution too high on our current model, just because that doesn't provide you the best FPS. But if you lower it down to 320 by 240, you kind of get a nice happy medium there. Anyway, and so for the script that a user would program in Python, it's really just this many lines of code. This is running tens of thousands, hundreds of thousands of lines of C code that all go on in the background to make this all operate, but we kind of wrap it all up in a really easy to use Python interface.
So I'm kind of we don't have the what's on your desk segment, Alessandro, lined up, but that would have been a perfect opportunity because he was showing it. That's really cool. In fact, this kind of brings up another question for me. I know that using the OpenMV camera you were talking about earlier about kind of like getting these data sets or facilitating the setup of these data sets, basically gathering these data sets, taking pictures of a bunch of stuff and training your models, right? And I remember the last time that we had you on our pre-series of Innovation Coffee, you were able to pull out your camera, take a picture of something or take many pictures and literally create a data set super easily. And this is something that I was just very impressed at. Are we able to kind of showcase that real quick? Because I thought that was really cool.
You're on mute, Kwabena.
Uh-oh. We lost his mic again. I still see, yeah.
But it was interesting actually. Last time on the previous episode, Kwabena actually launched with Edge Impulse a collaboration live on our stream. So it was fun to see actually.
Yeah, so the Edge Impulse thing is a pretty long segment if we want to do that right now. Not set up at all for it, but yes, you can train a neural network using the OpenMV cam and have that easily identify objects. It's just object classification right now, so it's not like a localization in the field of view, but it'll tell you what the camera is looking at them.
And maybe rather than showing it, because you're not set up, so I don't want to put we don't want to put you in the spot, but maybe we could talk through the features, because I think one interesting thing is that it's really easy to capture images and send the image over to Edge Impulse for the training, but also it uses, I believe, transfer learning, right? So it's really quick to train the network.
Oh, yeah. So more or less, ARM released something called CMIS-NN about 2 years ago. And so this increases the speed on microcontroller inferencing from to about 5 times what it was previously able to do. And using that in TensorFlow Lite, you can get about 12 to 16 FPS doing things like person detection, where you're looking at a picture and deciding, is there a person or no person in that particular picture. Mm-hmm.
And you're using
that uses transfer learning, yes.
Transfer learning, yeah. So it's how many pictures you have to take to actually train it effectively? More or less?
Well, I mean, realistically, if you're doing like an actual industrial purpose application, that's going to be something. So that was built using the Coco image data set with a person, and so that's on the order of 10,000 plus images. It's not that you need so many images for transfer learning to work. It's that you need a lot of images to encode all the possibilities, because the neural networks like to hard code what easy answer is there for a problem. So, for example, if you have a picture of a person in a room and they're always sitting, the neural network will kind of assume the chair is the person also. And so if it sees a chair, it'll assume that that's a person, or a person also could be a chair. So you really need to have a variety and a large mixture of all kinds of different things happening that you want the network to actually learn. And you can't have any like shortcut where there's some object nearby the object of interest that's always present that the network then may learn is a clue.
So I want to dive into. I want to bring up a topic here, and I want your kind of input or take on this. But I feel that these IDEs, especially kind of after looking at what you've done with Edge Impulse and facilitating the ability for developers to kind of build out applications and do things with your OpenMV camera, the whole kind of low code, no code thing comes into mind, right? And I know that there's still a lot going on, at this interface with your IDE, but I mean, I feel that in some ways you've kind of lowered that barrier to entry for people to actually get their hands on hardware, get your IDE and literally start building stuff. So I'm kind of curious, like, what is your take on this whole low code, no code model, where it's headed, and what is OpenMV doing to kind of facilitate this for developers?
Yeah. So I think the best example of that would be this. So let me share my screen again real quick.
And are you a fan of low code, no code? Like, are you a fan of that? Are you a fan of like bringing more developers into the mix here, trying to get them enabled?
Yeah. No, I totally agree with that. This is why I wanted to show this off. So here's an example of something I think that a lot of people will struggle with. Not struggle with, but want to do, and it just seems impossible without a desktop Linux system. So we're going to do HDMI output with the OpenMV cam, and we can do this using the LCD module that we have. And so we're going to do LCD. Let's see. What is the, oh man, I forget. It's, called, nope, it's not called that. I think I just called it, okay, it's just a resolution. So let's just say XGA. Okay, great. So then we can do this, and then we can do LCD display image. Let me see if this works. And did it go on? Oh, I got to actually plug the HDMI in. Great. Okay. Let me do that.
Is it plugged in?
Yeah.
This is the first question I have to ask my parents when they call me for help.
Okay. It worked. Great. Okay. Let me just raise the resolution of this real quick. Okay. So here I am. And here's a monitor that has what's going on there, as you can see. And it is going through an HDMI monitor. Didn't really set this up real quick, but we're driving an external display, and we're driving it at 1024 by 768 resolution, your standard XGA. And so this encapsulates the whole process of this little code I wrote there. That's doing HDMI LCD output, okay? It's really helpful to, it's upside down now, but what's really helpful to understand there is that we're outputting to an HDMI display with just less than 20 lines of code, okay? Wow. That's the power of low code, no code, as you mentioned. It really lets you do something. Let me see if I can get a better view of that. Okay, hold on. Yeah, there you go. This looks terrible, but anyway, yeah, but that's the power of low code, no code, is that you can drive a display with an OpenMV cam that simply. And the thing to to realize there is that would normally be, okay, I have to use Linux, I have to get a application processor, I have to figure out and fight so many different things, just because I just want to do literally just take camera input data and put it to a screen. Like, if that is your goal, that is 20 lines of code with OpenMV cam.
I feel like you could put like a big group of engineers in a room, and it would become such a debate as to whether or not low code, no code is the, the future. I mean, I feel that, it's definitely a divide right down the center, because there are people who just want to get that prototype out. They just want to get that thing built and showcase what they're capable of doing. And then we'll tackle all that back end stuff later, the lower parts in the stack later, but let's at least prove our concept here. So, I mean, I love that 20 lines of code. Something that would have taken someone a lot more work.
Well, it's really just about, I mean, a lot of the protocols, for example, that you want to do for rich data movement aren't really that complicated. It's just there's been so much built up around supporting them that you get into insane amounts of complication for no reason. For example, you may have noticed OpenMV cam was capturing camera data, and it was streaming to the IDE, which is a JPEG data stream, and it's also streaming a video to the HDMI display. So that was a fork of the display input. I didn't mention that, but that was happening right there more or less seamlessly. Like, JPEG compression is not insanely complicated. It's not that crazy of an algorithm, but if you want to do JPEG compression on a PC, that means libjpeg, and libjpeg isn't actually the best because it was written 20 years ago. So you got to download libjpeg turbo, because libjpeg turbo actually has the it actually uses the SIMD instructions on most processors. But if you're using libjpeg turbo, you might want to have the NVIDIA JPEG compressor, because that can do it even faster. And you see now we just have 3 JPEG libraries that each have different install requirements. And if you're using Docker to build your system image, now you have another idea concept to bring in there. And literally all you wanted to do was JPEG compression, but you now are hiring a full software engineer, and their whole time is spent fighting library dependency problems. And so that's the general problem we have with higher level systems, is that you get quickly, like, if you want to get the best performance, there's so much stuff you have to tackle. It obviously is worth it. I mean, the performance difference is 1,000x, 10,000x from what a microcontroller can do. But sometimes you're just trying to do a simple application, and in those times, then it's nice to be able to use a more simplistic system.
I mean, that said, though, there are challenges when it comes to like using libraries on microcontrollers as well, right? So, so that is still. So I think in that respect, the fact that you've got your IDE in MicroPython really helps, right? Because you don't have to worry about kind of installing your own dependencies locally, right? You could just run on the IDE, and it takes care of like the environment for you, right? I think that's super. It makes your life as a developer much simpler, right? Do you find that MicroPython has some limitations in your experience to this point, at this point, in terms of like what you've been doing with MicroPython? Is there things that that you would do differently, or that you've thought about?
It's more or less just the community size, I think. MicroPython's taken off pretty well, but not as big as you think it should have taken off. I'm not quite sure why. I think that, though, it's probably a deployment problem issue. like the OpenMV cam kind of releases MicroPython in a more usable way, but more or less right now, MicroPython really doesn't have a standardized IDE or way to get Python code onto a microcontroller in a way that makes it easy to use, and also do firmware updates in a reliable manner. It's very much kind of like right now you have to get that, at least from when I last checked it, you have to use command line tools to load up the new firmware images. And then debugging it still can be done in Python, but it's not as, we have a little bit more seamless interaction with the OpenMV cam, and it's a little bit more tricky to use. I think though CircuitPython, they've done a good job with Adafruit on making that more usable and user-friendly. It's definitely, though, I would say though, it's becoming more of like the future, just because you can move at a much higher cadence when you're trying to design something. An example, if you want to do matrix algebra and other various complex calculations in Python, that's super easy than when you compare it to doing that in C. Just a lot of things are just much more straightforward with MicroPython. And leveraging other people's libraries is super easy. Like the install of a library is just you drag and drop a file to a disk. That's how you install a library, because it's a Python module.
So real quick here, I want to get a question from the chat that came in from David. And also I want to remind everyone that if you have any questions for Kwabena or Alessandro or myself, please feel free to drop those in the chat. But this one comes from David, and to David, as he always asks and brings the conversation always back to autonomous in vehicles. Are there models for lane recognition and road following, any autonomous bot or vehicle activity going on? Just to give you a kind of like a little insight as to what David does, he hosts a lot of really cool meetups and things in his local area, all sorts of autonomous driving, remote control cars. I'm not even going to do justice explaining this, but he has a lot of really cool stuff going on around the autonomous car deal. So
yeah, I can talk about that. So we've been competing in something called DIY robocars in the Bay Area for a while. We don't do lane models for recognition. So instead, the system is just doing a more traditional computer vision approach. Basically, you do some lens correction on the image coming in, and then you do perspective correction to do a bird's eye view of the floor. And then after that, you can use an algorithm called histogram equalization that'll pump the contrast up of a line on the ground. And then you can use a very straightforward binary image segmentation, which is just looking at high, low contrast pixels, because the histogram equalization kind of segments that into a white line on the ground and black pavement. And then once you do that, then you use a linear regression to fit a line to the line on the ground, and then you can drive from that. And it's a model-less approach that more or less works on any type of bright line painted on a dark surface, or the opposite, more or less. It's not going to follow though between two line segments. It needs one line in the middle to follow. But if you use that code, and it's actually on GitHub right now, we built a whole line following robot. It works really well, though, for following a single line on the ground without any training. You just kind of drop the code and the robot will follow it.
I feel like
Sorry, Robert, go ahead.
I feel like someone could take that code and possibly adopt it or change it to maybe spread it out to two lines and bounce between. I've seen some videos that David has shared. His robots usually follow lines on the outside, not usually following a.
Oh, yeah. No, that's well, the thing is, the trick with doing that is actually, so when you think about when the robot's following lines on the outside, it's a harder problem to solve just because you can't always see those lines on the outside all the time. An example,
like that.
well, no, it's like depending on the robot's field of view. If you can see both lines at the edge at each time, then you can kind of break that down back into a single line problem. But sometimes though, what happens is one kind of disappears and you just have one wall, and then your perspective may not be enough to know how to follow one on the left or right. So definitely having a neural network is useful for the two line problem, just because it can help abstract you away from dealing with how do you see when when you don't actually have enough data to follow anything in particular.
And I should say, well, actually, while I say this, Kwabena, can you share, maybe even afterwards, can you share the link with us to the GitHub so that we can share it with everyone? And I was going to actually add that, you've been competing. So I've seen you competing with, competing at the DIY Robocar events. I think at Maker Faire, actually. It's quite impressive to see those challenges always, like those races. It's always quite cool to see different approaches to the problem, right? And I think we talked about this a while back, but has there been, obviously with the pandemic, I imagine there hasn't been any DIY Robocar events, right?
Not at all. So I've just been using that time to develop more OpenMV cam software, more or less.
Yeah.
Mm-hmm.
I was going to ask, has there been any advances there? But I imagine like it's been a bit stalled, right? So, yeah.
Oh, yeah. Well, it's given me a lot of time to work on drivers and other various things. So an example, the HDMI out, that wasn't a feature we were able to do before the pandemic. And so we've kind of developed something like that, being able to do, we're working on right now getting double buffering working. And so this will enable our software to pretty much process images while receiving a new frame constantly on the STM32 line of sensors. This is tricky actually, because we have about an 80 megabyte a second data input coming from the camera, and you actually have to get the DMA controllers and all the memory buffers that you're using to receive the data in the right location, so that the processor doesn't fall over on itself trying to actually receive that data when you're running at a high clip.
Cool. Mm-hmm. So I shared the link on the chat for everyone. I'll actually put it up here as well for everyone. So it's the Donkey Car master branch on GitHub, actually under OpenMV though. So it's OpenMV then Donkey Car. I was going to actually mention another thing actually that I think I really wanted to mention. So there is iShot JR, one of our friends, actually hosts a meetup on this evening actually, and they're going to talk. So he's going to have Larry, a friend of ours as well, talking about SIMD and how SIMD instructions can be used on Cortex M and Cortex A actually. Well, there's different Neon on one end and Helium on the other end. But
yeah, this is something that more people need to learn about how to use on a ARM microcontroller. So for desktop, it's not really so important because GCC is pretty heavily optimized to kind of inject those into your loops if you know how to write loops. But on microcontrollers, though, you almost never get to use these instructions. But if you know about them and you can kind of unlock how to code appropriately, it's very easy to get 2x the performance on many different algorithms that your microcontroller is running.
Do you actually use? Sorry, I was going to ask. Do you actually use ARM intrinsics in your code? Yeah, directly.
We started doing that because we met a performance optimizer, Larry Bitbank, last year, and he very much blew me away by how much he was able to speed up some of our code we wrote. So we wrote code in a very straightforward, generic C way where we thought, okay, everything's written very clear. The processor is just going to, the optimizer will figure out how to make it fast for us. We don't have to worry about that. And it's really not the case that the compiler does much at all the compiler will optimize things like Boolean expressions. It does nothing, though, at a high level in terms of like undoing loops for you. People show off pictures of like GCC doing that, and so it's kind of understood that that's possible on desktop computers per se, but it's not really the case. GCC does that in very, very rare instances of making code go much faster. Typically, the case is if you want to write fast code, you have to think about what is actually going to happen and then break out different loops that are as tight as possible for every single different instance of activity. An example being if you're like processing an image, right? Typically you have algorithms that look to the left and right of a current pixel and to the top and bottom of that. And as long as you're in the middle of the image, that's fine. But when you hit the boundaries, though, you have these boundary condition checks you have to do. And the boundary condition checks, you can write a loop that checks those boundary conditions every pixel. But if you're in the middle of the image, you're doing boundary condition checks that are kind of worthless all over the place, and they don't add any speed. And so what you really want to do is you want to split into a separate loop that does the boundary condition checks when you're running along the top, a separate loop for the boundary condition checks on the right side, a separate loop for the boundary condition checks on the bottom, a separate for the left, and then a separate one for the middle. And it's not obvious that you should write 5 different loops that all do the same thing. But the difference is each loop doesn't have the extra checks, and those checks burn a lot of CPU time.
Ayan brings up a good point here. I mean, there are FPGAs as well. And I mean, with an FPGA, couldn't you essentially program that logic in so that you had these things kind of functioning independently at a chip level?
Oh, yeah. What's interesting, though? I'm an FPGA programmer. I've done satellite FPGA coding. I have code in space, actually, for Planet Labs, where I used to work. Yeah, code in space. And it'll be up there for a few years. The satellites don't last forever, so they eventually fall down. So it won't be up there forever. But the FPGAs actually aren't better than microcontrollers nowadays. If you look at the integration level of like a modern Cortex M7 SoC, it is substantially bigger and more powerful than an FPGA that is at the same price. You need to be in the $3,000 chip territory, and I'm not kidding. Yeah, like FPGA, the really fun ones are $3,000 a chip. So if you're in that territory, FPGAs are great. But if you're not in that territory, if you're in like the $10 or so territory, FPGAs actually are not really competitive with modern day microcontrollers. Like if you look at a STM32, it has about a 3.4 gigabyte a second AXI bus in the center of it that's linking its internal RAMs to its main processor. The CPU running at 480 megahertz. If you try to like compile FPGA code with a lower end lattice part, you'll notice like your Fmax might be something on the order of 100 megahertz or less for your different algorithm, and a Cortex M comes out of the box running at 480, so it's 4 times faster. So unless you code, so like given that it can do 2 pixels per clock, it's going to be able to do 8 pixel processing per clock compared to what an FPGA can do. So your FPGA code needs to be out of the box really heroically good. Otherwise, the processor will trivially run faster than whatever you program on an FPGA.
So maybe a OpenMV XL, $5,000 base price with the big time FPGA in there. Maybe that's something in the future.
Oh yeah. Well, the way you get lots of speed into FPGA is you don't run it at a fast clock speed. You make your data path really wide. So what I'm talking about, like $3,000 FPGAs, is you do something with like a 256-bit data bus where you're processing 32 pixels or bytes per clock cycle. Then you have the hope of actually hitting a processor in terms of the speed. But remember, the like an STM32 is a 64-bit data bus running at a couple hundred megahertz, so it's already pretty fast.
I'm trying to keep up. I'm trying to keep up all these numbers that are going on. I'm like that meme with the guy with all these equations.
Yeah.
Like, oh.
No, I'm just saying though, like FPGAs sound awesome, but they actually, it takes a lot of work to make them go and be usable and actually outperform a microcontroller. You need to have really esoteric and high performance code, and typically that's only possible with the larger end chips, which have the resources to let you do huge parallel data buses.
Yeah.
Mm-hmm.
I feel like it would be a nice hackathon to like try and have an FPGA on one side and a Cortex M on the other side, and try to look at what do you need to do, because I think I used to like code write code for FPGAs when I was in university, right? And it's fun, right? Like thinking about like the parallel of an FPGA and being able to like speed up stuff in a parallel way. It's completely a different type of approach of coding, right? And I think it would be interesting to actually have that challenge of doing the same operations on the two cores, right? I mean, there are some interesting actually things though that are probably worth mentioning. Like there is new custom instructions actually that have been released, or at least they've been announced, and obviously we're still waiting for partners to like build silicon on it. But there's going to be some chips actually based on ARM with custom instructions that are going to kind of accelerate some calculations depending on the silicon. And the other thing I was going to say is actually ARM Helium will have 128-bit bus, so you can actually do 16-bit 16
8-bit multiplies per clock. So that's what I mean by like Helium though. When you factor that in, it's like, yeah, it actually will crunch a lot of data really, really quick. And so those kinds of things, and it's just so much easier to write code for these. Now it's not fully in parallel. Like the thing with a processor always is that it's doing one operation per clock, whereas FPGA does the whole pipeline in parallel. So, but from the standpoint of just this one operation though, the processor typically can beat the FPGA generally. It's only when you have a deep pipeline that's like many different operations all going where it makes a difference.
So can we take another question from the chat, Alessandro? Is that okay?
Yes.
Go ahead.
All right. So this one's from David again. I think this is along the lines of these pipelines, crunching all these numbers. Could the OpenMV cam be used as a first-person view cam aboard a drone or rover? Simultaneously, could you do object detection while controlling the drone with the camera view, or would there be a latency problem?
Not at all. We actually just finished making this thing go faster, which is a TV shield.
Here, I'm going to make it big real quick.
The TV shield. This is not the wireless one, so we sell this on our website. We have something called the wireless TV shield and TV shield. And more or less what this does is this is a SPI to NTSC output chip. And so it'll basically, and we have the SPI bus code all running in through it's basically running through a driver that does, there's a whole DMA process in the background with a triple buffer. So it doesn't block the main processor to output the current image buffer. That's just kind of happening all the time to the SPI chip. And anyway, given that solution, you can actually be capturing data, having the processor move data between buffers, and then hardware is taking care of actually outputting that to and creating an NTSC signal for you. And then that actually can be put through, we sell a wireless version of the shield that has a little RF transmitter that speeds up the NTS signal to 5 gigahertz to transmit that to a FPV goggles actually. And doing that, then you can pretty much, you can have more or less whatever vision data you want being streamed. And with OpenMV Cam, you're allowed to actually mark up the video data with all kinds of graphics and text. And you can actually bring in other vision data. So if you wanted to blend thermal and regular color vision data together, you can do that too, and then output that FPV stream.
Awesome. I hope that answers your question, David. And on that note, we haven't shared the website yet. So there is down here, openmv.io. Kwabena did mention that you can go get that particular device, and of course, all of the other OpenMV cool stuff on their website. So definitely go check out openmv.io if you're interested. Alessandro, did you have another question? Because there was something I wanted to share here. It's a particular project. I'm not sure, maybe Kwabena, maybe you've seen it, maybe you haven't, but I thought that this was really interesting. One of our community members, actually first, Alessandro, did you have any other questions real quick? Okay. So Arjit, one of our community members here, made a really cool project and posted it on Hackster. I just want to share the link here real quick because I think it's really cool. It's pneumonia detection using edge impulse and an OpenMV camera. So I'm going to post the link here in the comments as well for anyone who's interested in going and checking out this project. Maybe Kwabena, if you haven't seen it yet, maybe you go check that out too after the show. But cheers, Arjit. That's really cool that you're building stuff with the technology that you're seeing right here on the show. That's cool. So thank you.
Yeah, no, it's really cool to see. Like, there's a lot of interesting projects actually with OpenMV, and it's always interesting to see the new ones. Maybe the next thing we should do, Kwabena, is talk a little bit. So I know there is. We should tell everyone actually that there is Arduino Day coming up, right? So I'm going to post a link down here, and it's this Saturday actually, and I think it's a good opportunity, kind of in preparation to Arduino Day to talk perhaps about your collaboration with Arduino and the cool stuff that you're doing with Arduino. So yeah, I'll let you speak to that.
Yeah. So we went into partnership with Arduino last year, and we more or less have been helping develop a software environment. Hold on, let me see if this focuses. For the Arduino Portenta, and getting the camera on it working, more or less, which is a low resolution grayscale, low power camera. But more or less, this is a general purpose development system that kind of shows off the OpenMV cam functionality in a more professional package. So this guy has got on it the H7 processor, it's got SDRAM, it's got quad SPI flash, it's got a Wi-Fi/Bluetooth chip. It actually has a DisplayPort output chip over USB. It has a Ethernet MAC, USB high-speed PHY, so 480 megabits a second. And it also has what is it called? A cryptographic chip. So it can do signed, it can do public key signing in a secure way, where the private key is saved on a chip and cannot be physically accessed by anybody ever, such that you don't have to worry about anyone ever copying your private key, because it is literally inside of a chip and cannot be read out. And the chip is the only thing that has it.
Yeah, very interesting. I mean,
oh no, please.
What? My audio there?
No, you're there, Alessandro. Please, what I was going to say is not important.
No, it's always important, Robert.
Well, I was just going to say that's the kind of technology that goes behind a lot of these secure. Oh my gosh! And now I'm going to blank on it. It's okay, Alessandro. Go.
Well, no. You mean you need those chips because a lot of folks you want to do communications on internet, and you want to make sure that your device is actually secure. And if you just have your private key in your firmware, right, and your firmware is deployed on a whole bunch of products, that means it's the same private key per device. That can be bad if someone were to hack your firmware, which is usually possible. And so by having the private key literally stored in hardware on a chip that has no readout mechanism for getting the private key, the only thing that it does is sign stuff with the private key so that it can be decoded using your public key. That becomes much safer. Yeah.
Yeah, and I mean there is different levels of security as well, right? Like I'm not an expert, but there is obviously hardware security with a separate chip that as you said, hosts keeps the private keys and has communication protocol to sign the keys. But there is also interestingly hardware separation in kind of more modern chip architectures, like the ARM v8M has trust zone. So it's got a hardware security layer or hardware security separation, and you could have trusted firmware running on one of the two sides, right? That kind of, again, attestates keys or signs keys and does attestation and all that. So there is that as well. And yeah, I think it's interesting that in a lot of cases, it's interesting that you mentioned that, because in a lot of cases, security is kind of taken as an afterthought, and it's important to make sure that the board that you're picking for prototyping, the board that you're picking, and the chip that you're picking for actually going to develop to product is actually got the security features that you need for your device, right? And it's good that Arduino is actually coming up with some really interesting boards that have more kind of professional features and actually make the boards actual product ready, right? So the Portenta is a really interesting board. How have you found? Is there any specific highlights that you found on the Portenta? Actually, talking about that.
Specific highlights. Well, what's nice is that they got the high-speed USB working, and we also got Wi-Fi and Bluetooth working with it. And so this is non-crappy Wi-Fi. This can do 50 megabits a second of data transfer. And so that kind of Wi-Fi speed, it can actually move, rather large images. Similarly for Ethernet, it has 100 megabits Ethernet PHY, and the STM32 has a full hardware offload system for that. So the PHY on board, the STM32, the MAC, that talks to the Ethernet PHY, does multiple TCP/UDP packets in flight. It does the checksum computation for these packets, so the processor can literally, and it also does packet segmentation for you. So the processor literally can just output, here's a TCP packet, and it has this data in it, and then just tell a piece of DMA hardware, send it. And the DMA hardware will take care of segmenting that into appropriate chunks, doing checksum calculations for it and sending that. And all that's important to say that the system actually gets like a good throughput and can actually output data at a fast clip without the processor totally being bogged down and falling all over itself trying to handle that data rate.
So Alessandro, we're towards the end of the episode. Kwabena, we've covered a whole bunch of stuff. I really want to try one of these segments here if we can. I'm gonna hit a button here.
Mm-hmm.
Did that work? All right. Cool. So newsflash, we were talking about security. We were talking about all this cool stuff. In the last week, we've released 5 new videos. Newsflash, 5 new videos, and there are 3 more to come on Parsec, the platform abstraction for security. And I'm going to share the first video here in the comments section. This is part 1. And in the description of part 1, you can go find the rest of these videos. This is part of a series we call the ARM Software Developer Breakdown, featuring yours truly as the host. We brought on one of our folks from ARM, Paul Howard, who did all the demo for us. But very interesting series, and I am interested in hearing everyone's input here as you go watch this series and tell us what you think about it, so that we can make these videos better. Right? They're made for you, the developer community. How did that segment go? I just wanted to try it. Sorry, Kwabena, just interrupting.
That was awesome.
Very cool.
Okay. We've got more coming. We've got more coming. Actually, we've got a couple more coming. So I'm excited for those other segments. We still have to try them. But I think actually maybe we could use it again. I really liked it, Robert. Maybe we could use it again and have Kwabena talk about his latest developments. So maybe you could click on it again. Go on.
All right, you ready? Ready, Kwabena? This is for you.
Okay, it's too much. It's too much. All I would like to say is this is the OpenMV Cam Pure Thermal. It's what you saw outputting the HDMI before. So it's got a color camera right here, 5 megapixel, the OV5640. Let me see if my camera will go into focus. There we go. It's got a FLIR Lepton 3.5 attachment. It also has the ST VLX 53 laser rangefinder up to 2 meters. Comes with 64 megabytes of SDRAM, H7 micro SD slot. This is a mount for a 1/4-inch screw, so you can mount it on a tripod. OpenMV Cam Shield connector, LCD screen on the back. Okay, a touch LCD screen, 800 by 480. Wi-Fi, HDMI output, and USB-C and battery. And we're going to be launching this product actually in April. So coming right up.
I was just looking at the website and I couldn't find it. So that answers the question. In April.
Yes, that's the Group Gets OpenMV Pure Thermal. I put that in the link.
Cool.
Hold on.
Yeah, that's exciting. I mean, I'm looking at your products page. You guys got a bunch of really cool stuff.
Yeah, as I said, like they never stop. I mean, probably never stops. And Abraham, actually, like you guys are just on fire.
All right, here you go. That's the latest thing. So this is what we're doing to push the OpenMV Cam to the max. It's not available yet, but we're going to launch it pretty much next month. Just a few little things I have to check out to make sure that the hardware is ready. But we kind of finally developed it. It does actually utilize pretty much every feature on board one of these processors. And
should add
everything wide open.
Yeah, I should add real quick, like Group Gets, just so you know, like they're a really cool crowdfunding site. We've used it before when I was with 96 boards, and they usually won't take hardware unless it's like, a proven working piece of hardware. So once you see something on Group Gets, you're pretty much guaranteed that, if you support that piece of hardware, you're going to get it in hands. It's not just like something that doesn't exist. Like, in Kickstarter, a lot of times you're just funding something that they want to build. This is something that's built. You saw it in Quabana's hands already. So it's there. And, if you want to support that project, that'd be awesome.
Yeah. And the idea behind for that, it's not going to be particularly cheap. But people love FLIRs and they're willing to pay money for them. But the whole point of this product is to really become like the first actually like decently nice open source thermal camera for people to use. So like a lot of people have done like, mixed thermal IR vision cameras, and it's this hacky kind of project where the hardware is not nicely done and it's like a bunch of dev boards stacked together and other various things. And so this is the first one that's like super professional level quality for everyone to kind of touch and use.
So we have a question from Larry, actually. Any problems with supply shortages for the board?
Yeah. So we haven't built the board yet. We have noticed though that chip market is crazy right now. I was talking to my contract manufacturer yesterday, and they were telling me that we're trying to go do another manufacturing run for OpenMV cams because we continuously do that all year round. And they were telling me that, hey, the price of the ST chip went up. And I was like, okay, just by a little bit. And they said 6%. And I was like, oh, only 6%. And they said, sorry, 60%. And there's shenanigans going on. Like we've purchased products already, and the distributors like telling our contract manufacturer that, hey, they want to revoke the chips that we already bought and give them to another customer because that other customer is willing to pay more. And our contract manufacturers had to fight for us to keep the products going.
One of the biggest supply issues, to this point, the board is one thing, all the components, of course, are another thing, but is the LCD screen. So in the past, I've heard that these, by the time you can actually get your hands on a big enough supply, that either that particular screen is no longer available anymore, end of life, or they move on to another company. I've heard that LCDs are very hard to come by, and I'm looking right now at the group kits. It looks like this particular board has an LCD on it on the other side.
Oh yeah. We're using Buy Display though. We're just getting a display from another company who sources these from many other companies.
Oh, okay, cool.
And it's not particularly esoteric. So we're pretty confident we'll have quality and stock for this display.
Excellent. Very cool.
Mm-hmm. Awesome. So go check it out. This is the link below. And we're at the top of the hour. So I just wanted to give you a chance to do any last shameless plug or like say any last comments or thoughts that you have, Quabana. And then we can wrap up.
That's it. Thank you for having me on, and I hope that you can, that you found the OpenMV cam interesting and you want to check it out. The product is a vision where we're constantly improving it and making it better. The goal, though, is really to build out an ecosystem for people to be able to do computer vision on a microcontroller. So this is without having an operating system, and this is to enable many different products in the future, hopefully, that can run computer vision algorithms on very, very low-end hardware. This is the kind of idea where, let's say you want to build a product that has a camera in it, and you need the cost of the bill of materials to be less than $20 or less than $10. We want to enable products like that where you have all the vision code running on one chip that may not even have SD-RAM attached or extra flash.
And on that note, I was going to say, oh crap, I forgot what I was going to say. I just blanked as well. I think today's the.
It's okay. No, it's okay. It's okay. Should we close it out?
Yeah, let's wrap up. I think for everyone, go check out openmv.io. And oh yes, that's what I was going to say. If people want new features or new things related to OpenMV, or if they've got issues, how do they find or how do they talk to you? That was my question.
We have a forums. You can go on there, register, and post a link, or you can just email us.
Awesome.
Great. Well, on behalf of I should say myself and the ARM developer community, thank you so much, Quabana. This has just been great. Thank you for your time. I know it's very valuable, so we appreciate having you here. All the viewers out there, thank you so much for joining us and spending your valuable hour with us. It's been awesome. Please like the video. It really helps us out a lot. Follow the channel, ARM Software Developers. And back to you, Alessandro. Let's close this out. You get to hit the last button.
Yeah, let's close it. Thank you, Kwabena. It's always a pleasure to speak to you, and it's always nice to hear about your latest developments. And thank you all for watching, and we'll be back next week on Tuesday. Bye, everyone.
ARM Innovator.
Bye.